Hello, my name is Blake Prout and I've been working with an autonomous boat, and I'm going to kind of go through what we've done with Mission Planner and how we connected the Pixhawk to the Arduino Mega. So first, what you got to do is you have to connect your Pixhawk to your computer. You can do that two different ways. You can connect a cord straight from the Pixhawk to your computer, or you can also use what's called a telemetry, and you can buy two telemetries, one for in our case the boat, and then one for the computer, and they will be able to communicate with each other. So right now, the first thing you want to do is start up Mission Planner. I am using build 1.3.41. It's a little bit of an older version, but it works pretty well for me. The next thing you want to do is you want to connect your Pixhawk to your Mission Planner. So what you want to do is you want to go to this drop down arrow, and right now you can see that it has auto, TCP, UDP, UDPCI, and COM11 Silicon Labs. What you want to do is you want to click on this COM11, because this is where your Pixhawk is connected to your computer. So you want to select this, and usually with the telemetries that I am using, a baud rate of 557,600 is the standard baud rate. They usually can't communicate much faster than that. So just to be on the safe side, I would use that baud rate when using telemetries. And you can tell the telemetries are paired when telemetries are paired when the lights are on the telemetries are not blinking. So you will have a red light and a green light, and if the green light is a solid green light, then that means that the telemetries are paired. So what I want to do right now is I am turning on the Pixhawk, and I should be able to see that my telemetries are both a solid green light, which they are. And when that occurs, I can go to connect. So I'm just going to hit connect, and it's going to pull up this Mavlink connection. And when it does that, it's got to get these different parameters. So just wait for that. Alright. And it is done. Let me just bring this up. Alright, and then you should get this disconnect. You can see that it is connected right now. Alright, so about the Pixhawk. So this would be what the Pixhawk would see if it had like a camera on it. I'm going to move the Pixhawk around, and you should be able to see that little window move as well. So if I point it up towards the sky, it moves up. If I push it down, it moves down, left, right. You kind of get the picture of what this is doing. And you can see down below it that these, in this quick actions tab, you can see the altitude, the different speeds, the distance to waypoint, yaw, different things like that. So the first thing after you do that, I'm going to go over setting up the Pixhawk. So you can go to this initial setup, and first thing you want to do is install the firmware, and after that you'll go to mandatory hardware. So you can either go through this, so you can set up all these different things. So just go through it. It should tell you how it's done. Just basically follow the rules through here. I don't like this. I think there's an easier way to do this. So I'll show you in a second. But the first thing you want to do is you want to go to flight modes. And what flight modes is basically it's your different modes that you can have on your Pixhawk. So right now I am only using flight mode 1 and flight mode 6, and that's because my pulse width modulation only goes from 900, so it's between the 0 and 1230, and it's has a pulse width modulation of greater than 1900 when I flip the switch up. So that's why I'm using these two flight modes. So if I turn my controller on, you should, so you can see my current pulse width modulations right now. So when I flip the switch, see how it changed to flight mode 6? So flight mode 6 is already set to manual. And what that means is basically I can control everything using my controller. And when I switch it up, it goes to auto. And this is, you can read my current pulse width modulation change. You can't really change your pulse width modulation, not that I have found. But if you can definitely put it on a knob. But right now we only need these two modes, so it works for me. And I am using a FlySky radio controller, just an FST6, and I'm going to go through. This is what I have done. I went to the wizard, and this is basically how I set up Mission Planner and the Pixhawk. So the first thing you want to do is select your vehicle. So we are using a boat, and it obviously doesn't have any of this, but our boat works a lot like a rover. So what I did is we clicked it on rover. Let's see, hit next. You select your different COM ports. You can see here, and then this is basically going to take you through all the basic setup of setting your Pixhawk up. After that, you can hear my controller is dying, so I'm going to turn that off. You want to go to configuration, and after configuration you go to, what I like to do first is go to full parameter list, and you can kind of see the different, this is all the different modes in Pixhawk. So what we want to do is we want to go to these RC modes, and you want to go to, here is different modes. So you want to set your mode channel to whatever channel that you are using on your controller. Remember how I said I was using channel 5? So you can change this to different channels on your controller. So I'm using 5, so I set the mode channel as 5. And here you can see the different modes that I was in. So when you go to initial setup, cancel that. Flight modes. This is all the same as in the configuration tab. So we want to go to RC7. Alright, and I passed it. Here we go, RC7. So here you can see all these different modes that it allows. And what we want is a camera trigger. So the way that we are triggering and getting the Arduino to work with the Pixhawk is we are doing a camera trigger. So to my knowledge, the camera trigger is the only function in Pixhawk that will send a pulse to the Arduino and allow it to start up. So what we're going to do is we're going to go into here and click, change this to 10. It should be, usually it's disabled, so it's usually a 0, so you want to change RC7 function to 10. And that will, you can see here, it'll change it to a camera trigger. And after you've done that, we can go to initial setup again, optional hardware, and you can go to camera gimbal. Now here you can see this is a camera, and this is where you want RC7 right here. So you can drop down and you can go to all these different RC. We're using RC7 because that's what we set our camera in. So go to RC7 and you want to set a min and a max for your pulse width modulation. And since my pulse width started at 900 around there, so I set my min to be 800 and my max to be 2000 since it went up to my pulse width when it switched up, it went to about 1850 I think. So what we want to do is we want to set a value when we trigger the camera. So we want to change the pulse width. So if it's not pushed, you can't see it right now, but this is supposed to say like 1,000 or anything you want, basically a lower number. And when it is pushed, you want to have it to be a higher number. So I just selected, you can't see, it's 1850, and then this is about, I think it's 1,000, and we have a duration of 20 milliseconds, or 21/10 of a second, so it's like 2 seconds. Then we can go to, after that is all set up, I'm going to basically show you the code that allows us to do this. So how I said we're using our Arduino. Let me see if I can find it. Here we go. So we connected the Pixhawk to the Arduino using a ground wire and then also a signal wire coming out of the Pixhawk from RC pins 7. So there's, in each of the Pixhawk there's a power, a signal, and a ground. So you connect the ground to the ground on the Arduino, and we connected the trigger pin on pin 30 on the Arduino Mega. It can be any pin, so we just selected 30 because it was available. So then we come here and we make a variable called trig pin, and then down here in our loop we go to our if statement. So we create a pulse in. So what this does is it reads the pulse, and if this pulse is high, meaning that it is greater than 1800, and since I set our pulse to be an 1850, so if our pulse is greater than 1800, it is going to run this code and basically do all this. This is part of our testing, so none of that matters, but you need a pulse in function and a value greater than or a value lower than your greatest value when you give it a signal. Okay, and also you can trigger this. So if we want to trigger this, we want to go to actions. We want to go to the drop down menu on the first tab, go down to trigger camera now. And what you want to do is, whenever you want to trigger the Pixhawk to send a signal to the Arduino, you're going to go to trigger camera now and then click do action. And this basically does the action, basically sends a signal to the Arduino. You can also arm and disarm the Pixhawk from here. And that's all you really need this for. So now we're going to go to flight plan, and here, this is a pond that we are taking readings in. And you see this little waypoint, it's called home, or H stands for home. And how you set that is you basically right click, go to set home here. So if I want to move it, let's say I want to set home over here, I can do that. You can also click and drag. And if you want to set a waypoint, what you want to do is you want to just left click, and you can set different waypoints. Easy as that. You can also delete the waypoints by right clicking and hitting delete waypoint. Alright, so what I want to do right now is I'm going to bring up I don't want to do that. So I'm going to set a waypoint right here, and at each waypoint you want to set 3 points. So, and I'll explain why in a second. So you want to click and drag them right over the top of each other. And the reason why we're doing this is we want to be able to, in our case, we want to be able to trigger the Pixhawk to send a signal to the Arduino and have the Arduino do the different conditions that it's supposed to do. So the first thing we need to do is set it a waypoint. So that's what the first point does. So we can leave everything the same. Next thing we want to do is we want to trigger the camera. So this is basically triggering the Arduino. So we want to go to do set camera trigger distance. And what this does is basically just triggers the camera and allows it to take a reading, in our case. The next thing you want to do is wait for the Arduino to finish taking the readings. So we want to go to loiter. So we're loitering. In our case, we want to loiter for 30 seconds. So we're going to go to time and put 30 seconds. And then this should wait 30 seconds for it to take the reading before it goes on to the next waypoint. And then we can go click here and do the same thing for this. And when you want to save this, you want to go to write waypoints, click this, and it should be sending your waypoints and it'll finish. That's basically how you will set up your Pixhawk. And that's all I have for you today. So right now we are going to different locations and driving the boat. You can't see it, but we are driving the boat and it is logging it with the Pixhawk on Mission Planner. And we are just in the flight data mode, and you can see where the boat has gone and where it has started.